Hey Algebra 1, so today we're going to look at graphing linear equations in standard form. And one complaint that I have about a lot of math classes is that they'll use vocabulary that you're not familiar with. And we haven't talked about what standard form is, so let's take a moment to talk about standard form. So far, you've had equations of lines presented to you in this format. And this format is slope-intercept form, where m is a number, its slope, and b is a number, and it could be 0 for either of these, but b is a number, it's the y-intercept. And then you've got a plane x and a plane y, and when you graph them, they're lines. Well, you can also write these in a different format, and it's called standard form, and it looks like this. It's ax plus by equals c. So there's some number in front of the x, some number in front of the y, or they could be zeros as well. And then there's some number out here. It could also be 0 if you want, if it needs to be. But anyway, we're going to be graphing from this format today. This is called standard form. Why we start here, I don't really know. So let's just dive in, I guess. All right, so we're going to start out by graphing. Here's our objectives. We're going to graph equations of horizontal and vertical lines. And it's easy and hard at the same time. It's easy to do, but it's hard to kind of remember sometimes which is which. So I'll hopefully help you with that some. We're also going to graph linear equations from standard form using intercepts, and that's pretty interesting, okay? And then finally, we're going to use linear equations in standard form to model real-life problems. We're not actually going to solve anything today, so I don't know why it says solve, but that's all right. All right, so here we go. It turns out that if essentially a is 0, it wipes out the x, and you're just left with the y value. When you go to graph points that satisfy that relationship, they're going to form a line, okay? And if it's just y, it's going to be horizontal. Now, part of the reason for that is, like, if you've got y equals 5, part of the reason it's horizontal is because if you tried to make some input-outputs, some ordered pairs, for any x you think of, so you might think of -2, 0, 1. For any x you think of, there's no x in here, but what is y always going to be? It's always going to be 5. So when you plot -2, you would go up 5 and make a dot, and 0, and you go up 5, make a dot, and at 1, you would go up 5 and make a dot. And no matter what you plug in for x, it's going to be on this line right here. So it ends up forming a horizontal line. So if it's just y with no x, it's going to be horizontal. If it's just x with no y, it's going to be vertical. And it's kind of the same justification. So the y is gone. So if you're like trying to plug in points that satisfy something, so let's say we got x equals 3. You might think, oh, I'm going to plug in any x I want. Well, guess what? You can't. 3 is your only option. But y, because it's not in the equation, can be anything at all. It could be -2, it could be 0, it could be 5. And when you plot these points, you'll see pretty quickly 3, 0, 3, 5, 3, -2, that they're all on this vertical line at x equals 3. All at this vertical line of x equals 3. When it was y's, they were all at this horizontal line, y equals 5. So anyway, that's how this works. It's easy to do, but it's kind of hard to remember which is which. So let's practice down here. There's no, it says to graph, but there's no graph paper for you, so let's draw an xy coordinate as best we can freehand. And y equals 4. Well, y equals 4 means y's value is going to be 4 no matter what x is, and that forms a horizontal line at y's value of 4. So I'm going to use a straight edge actually to graph that line. And we could have put partial values in. We're going to connect it is what I'm getting at. We're going to put arrows on it. It's a line. It is continuous. It's continuous data because we came up with all possible x's here. All right. So then for x equals 2, well, x has to be -2. Y can be anything at once. And what happens is, let's draw our xy axes first. What happens is x is always -2, but y can be anything. We end up with having a vertical line at x equals -2. It's vertical. Okay, so yeah, that's it. You're going to want to practice. Hopefully we got a lot of practice for you, or enough, I guess, so that you get the hang of which is which. Okay, so yep, just to review, y equals 4 is horizontal. X equals -2 is vertical. Okay, so the next thing we're going to do is we're going to graph linear equations in standard form using intercepts, okay? So intercepts, what do we mean by x-intercept? What do we mean by y-intercept? Well, an x-intercept of a graph is the x-coordinate of a point where the graph crosses the x-axis. The y-intercept is the y counterpart, the y-coordinate of a point where the graph crosses the y-axis. So what I want you to do is draw another xy axes and take your straight edge and draw a slanty line in here. Doesn't matter where. But I want to talk about where the x-intercept is, where the y-intercept is. So the x-intercept is where the graph, the line, crosses the x-axis. So it's right there. That's our x-intercept. And it might be 1, 2, 3, 4. It'll be like x equals 4. That is where it crosses the x-axis. That is my x-intercept. It also has, you can think of it as a coordinate. It's 4, 0. That's my x-intercept. Where it crosses the y-axis, that's going to be right here. And we'll make it easy. We'll say that that's at y equals -2. You can also think of this as a coordinate. X's value is 0. Y's value is -2. That's our y-intercept. Well, class, it turns out 2 points determine a line. We talk more about this in geometry, but it's kind of critical to what we're about to do. What we're going to do is we're going to take equations written in standard form. We're going to find the x-intercept, graph it. We're going to find the y-intercept, graph it. And then we're going to take our straight edge and connect it to make the line. And it turns out anything on the line is a solution. The x and y are solutions to the equation, which is pretty cool. All right, so let's flip it over and do this. Use the intercepts to graph an equation. All right, so graph the equation x plus 2y equals 4. And they tell us to find the x-intercept. Well, if you're at the x-intercept, your y value has to be 0. So what you do is you put 0 in for y. And then you solve for x to get your x-intercept. 2 times 0 is 0. X plus 0 is x. We get x equals 4, or another way to think of it is 4, 0. And we're going to plot that on the graph. X-intercept crosses the x-intercept at 4. Crosses the x-axis at 4. To find the y-intercept, you substitute 0 for x and solve for y. Divide the 2 over. Y is equal to 2. But you can think of this as a coordinate as well. 0, 2. And you go down there, and so we've got our x-intercept, our y-intercept. 2 points determines a line, which is pretty nice way to do it. All right. And voila, we have our line. Yeah, let's get this in our notes. 2 points make a line, yeah. 2 points make a line. All right, well, let's look at an application problem. And this is a good application problem. This is interesting. One thing I don't like about this problem is I don't think a model of the situation would actually be a line. I think there would be gaps in it. I think it would be discrete data. But this says to write an equation to model this situation and then graph it. So we're graphing the equation, not the actual situation. So it says you are helping to plan an awards banquet for your school. You need to rent tables to seat 180 people. So we've got 180 people total. But the tables come in 2 sizes. Small tables seat 4 and large tables seat 6. Well, notice they're not asking any question here. They just want us to write an equation to model this situation. And the reason it's hard to get a single answer is it's going to depend. If you have 2 small tables, that's going to adjust the number of large tables you have, and vice versa. So there's multiple solutions to this. And when there's multiple solutions to something, it's often beneficial to graph the situation and see what it looks like. All right, so to write an equation to model this situation, we've got 2 unknowns here, 2 variables. We've got small tables and large tables. And the equation I'm thinking of is 4 people for every small table plus 6 people for every large table is going to be 180. And that's written in standard form. Now to graph this, we are going to get the x-intercept and the y-intercept to graph it. So to find the x-intercept, if you recall, you put 0 in for y. And I'm going to be kind of quick with this. If I put a 0 in here, it's gone. I'm going to be left with 4x equals 180. Divide by 4, and x is equal to 45, or 45, 0 as a coordinate. For the y-intercept, we put x in for 0, so that's gone. And then we get 6y equals 180. Divide by 6, y is equal to 30, 0, 30. And on this chart, they didn't give us any numbers, so we can't go by ones because that won't get us up to 45. And somebody in first hour suggested going by 5s, and that worked out nice. So we'll go 5, 10, 15, 20, 25, 30, 35, 40, 45. And yeah, we went by 10s going up as well. We could have gone by something else, 3s, but that's always weird, I think, to go by 3s. It's common to go by 5s, 10s, or 2s. But yeah, so we'll go 5, 10, 15, 20, 25, 30, 35, 40. I don't know why I keep going other than because it sounds fun. All right, so we go 45, 0, make a dot. 0, 30, make a dot. Take your straight edge, connect those dots. And then a common question after you graph your line. Notice I'm not going to put arrows on this. I mean, really, technically you would, but in reality, this was about tables, and you can't have negative tables. But what's fascinating about this is any equation that is on the line is a solution to the table problem. So you can look at where it hits nicely. Those should be solutions. So 30 and 10 and 15 and 20, those should plug into your equation and get the right answer. And those would be solutions to your table problem. All right, thanks a lot for watching. Have a good day.